All right, this is section 11.2, simplifying rational expressions. So first of all, let's just look at a simple fraction. We have 2/6, and you all know that when you want to reduce that 2/6, that you find the common factor in the numerator and the denominator. In this case, it's 2, because 2 times 3 is 6, and then 2 by itself, or you could think of it as 2 times 1, right? And then from there, you cancel out your common factors, and you're left with 1/3. Well, it's the same way when you're simplifying rational expressions if you want to reduce them. So here is a rational expression there in the red. All they did was they factored the numerator and the denominator. And so they took this trinomial square and they factored it. All right? And then from there, they looked at does it have a common factor? So you can think of this as x plus 2 grouped together. It has a common factor of x plus 2 and x plus 2 on the top and the bottom. So we canceled those out. Now remember, think of this as like saying times 1. So when it reduced, we ended up with 1 divided by x plus 3 in the blue. So we started with the red, we reduced the fraction to what we've got there in the blue. It's the same idea. We're using the same basic arithmetic rules, all right? Only we're using rational expressions. There is one slight difference here, and we'll talk about that. So again, they're similar, and then remember that the factor of 1 is left when the entire numerator is canceled, so don't forget to put your 1 in there. So let me show you what the slight difference is and why it's important first. So let's say I'm going to evaluate x equals a -2. I'm going to plug in x equals a -2 into the original expression, right? This is the original expression there in red. So I'm going to plug it in. Every place that there is an x, I'm plugging in -2. I'm going to simplify it. And when I simplify, you notice everything cancels out and we end up with 0 divided by 0. Well, that's undefined, right? We talked about that. So that's an undefined answer. Now let's take our reduced one in blue and let's plug in a -2. And when we simplified it, we ended up getting 1 equals 1. Well, if these two are said to be equal, right? They're equal, they're supposed to be equal values. How come we're getting two different types of answers when we plug in -2? One is undefined and one is defined. All right? So the domain of the original expression is different from the domain of the reduced expression. And so they come up with this rule, and you need to know this, that two rational expressions are equal only if they have the same domain. So how can we say these two are equal when they have different domains? Well, to reconcile this issue, you need to notate the excluded value of x that causes the original expression to be undefined and is no longer found in the reduced expression. So what you would do by notating it is you would take the reduced expression, which is the blue one, and you would say that the answer is 1 divided by x plus 3, but you have to denote where x cannot be a -2. In other words, x can be anything except for x cannot be a -2. And so that is the slight difference of what you have to do when you're simplifying your rational expressions. All right, we're going to do some more of these. So here in the red, I have this rational expression, and what I've done there in the black is I factored it, right? There's a common 2 that factored out, right? Factored this 2 out of the first expression, and then the trinomial factor to be x plus 4 times x plus 3. And from there, then, we can cancel out the common factors of x plus 3 plus x plus 3. You're going to take, and you get this reduced 2, right? This reduced 2 over x plus 4. That's what you're left with. That's your reduced fraction. But you have to denote what excluded values x cannot be. So how do you do that? Well, you take what you canceled out, You set that equal to 0. You solve for x. In this case, x equals a -3. And now you're going to notate that the excluded value is x cannot be a -3. So when you write your final answer, this is what you have to have. You have to have the reduced fraction with this notation that x cannot be a -3. Let's do another one. So you might try this one on your own if you want to stop the video and then come back. Again, you're going to simplify by factoring the numerator and factoring the denominator. Notice here the numerator has a GCF of 3 and the denominator has a GCF of 5. So we factored the 3 and the 5 out, and we were left with x plus 2 times x plus 2, and those canceled out. So then our answer, well, first of all, we got to know what are we going to notate. So I'm going to take what we canceled out here in the denominator, set it equal to 0, solve for x, and this is going to be the notation that we have to find, or that we have to write. So your answer is going to be 3/5, where x cannot equal 2. So we reduced the fraction and we made this notation. Let's look at this next one. We have 2x plus 8 divided by x squared minus 16. Well, the numerator that has a GCF of 2, so they factored a 2 out. And the denominator, that is a difference of squares. That's a special pattern, right? So you should automatically know that that x squared minus 16 is going to factor to be x plus 4 times x minus 4. Then you can cancel out your common factors that you have on the top and on the bottom, which gives you then the fraction 2 divided by x minus 4. But you have to do that notation. The notation is what? Well, this is what we canceled out here in the bottom. We set it equal to 0. We solved for x. So we have to notate that x cannot be a -4. So you're going to again say 2 divided by x minus 4, where x cannot equal 4. Again, this is your final answer. So it's a good opportunity for you to practice your factoring. You just need to remember how to factor your polynomials, right? But I think it's a straightforward idea. Let's look at this one. Here, slightly a little different. Didn't factor anything out of the numerator. In the denominator, though, I factored out a 2. And now we're looking at this, right? And so I'm going to rewrite this where I'm going to put the x in front and the 2 behind. And when I do that, this is what I get. It's a -x plus 2. Now looking, this is not the same thing. One's a positive x and one's a -2, and one's, they're opposite. One's positive 2, one's -2, one's positive x, one's negative x. Not the same thing. But I can switch the signs if I factor out a -1. So here I've gone from here and I'm factoring out a -1. Remember, a -1 times x is a -x. Right? A -1 times a -2 is a positive 2. So I've just factored out a -1, and that just changed the signs. Now I have common factors where I can cancel that out and that out. Now I'm left with -1/2, and you can look at this and mentally know that x cannot be 2, right? Because 2 minus 2 is what's going to give you 0, right? So you should be able, instead of having to go up and do it all this way, you should be able to look at it usually pretty easily and determine what x cannot be. Now you might want to try this one on your own. Stop the video and then come back. Looking on this one, we have 3, well, the numerator is divisible by 3. And then the bottom one, we can factor to be x plus 3 times x minus 7. Make sure you're doing your check steps, checking that middle term. Make sure you factored it correctly. Notice that I'm going to take then and put this, I'm going to change the order of these right here in my next step and put that -x in front. This is not the same thing. We cannot cancel it out, but we can factor out we can factor out here a negative. So that's what they've done. They're factoring out a negative, which now changes this to positive and this to negative, right? So now that we've changed our signs, we can cancel out the x minus 7, and we're left with a negative 3 divided by x plus 3. Notice that x cannot be 7, right? Because 7 minus 7 here would give me 0. And 0 times anything is 0. So again, you have to denote what value you have to exclude. Pretty simple. Now, what about if you have multiple variables? What happens? Well, here's an equation where we have two variables. We have an x and we have a y. So the first thing you're going to do is you're going to reduce the fraction. The numerator here, this one here, right here, is a difference of squares, right? And so naturally we factored in x plus y times x minus y. Here they have factored out just the common factor of 3. All right. From there you can cancel the common factors. And you still are going to do the same thing. You're going to take what's inside here and that we canceled out. We're going to set it equal to 0. Only this time you're going to just solve for one of the variables. You can either solve for y or you can solve for x. I chose to solve for x. So when I solve for x, I end up with x equals a negative y. And so you're just going to denote that the excluded value is x cannot be a negative y. So this again was how you would write your answer. We've got our reduced fraction and we're saying where x cannot equal a negative y. Here's another one. Now, this one has how many terms in the numerator? 1, 2, 3, 4, right? And in the denominator, it has 1, 2, 3, 4, right? So again, when factoring, go through your factor rules. The first thing you ask, is there a GCF? No. Is it a special pattern? A difference of squares or trinomial square? No. It's not even, it's bigger than a trinomial, right? And so the next one is a trinomial. Can you factor it real easy with trial and error? Can you use the quadratic formula or taking the root? Well, no, because it is 4 or more. You remember that when you have 4 or more terms, you're going to regroup. You remember regrouping when we factor? So I'm going to take these and I'm going to regroup them. So here they are. I've grouped this one and I grouped the second one. Notice that this minus 3x I wrote as a plus minus 3x. All right. All right. Now we regroup the top. Let's regroup the bottom into 2's. Then you're going to look at each group and ask, can I factor it? And of course, basically you're looking for a GCF, right? So looking at this first group right here, they have a GCF of y, right? Looking at this group, it has a GCF of the negative 3. This group has a GCF of x. And this group has a GCF of y. So I'm going to factor all those GCFs out. So that's what I did. I took this y, right, and I factored it out. I took the negative 3 and I distributed it out, and so forth. For each group is what I've done there. Always go back and check if you can. All right. Now, from here, you're going to look at, since we factored out the GCFs of the groups, we're going to look here. We have this whole thing plus this whole thing. Well, they have two terms. Is there a GCF in these two terms? Sure, the x plus the y. So I'm going to factor out x plus y, and that's going to leave me with the y minus 3. So that's what I'm doing in this next step. Here, had an x minus 3 and an x minus 3. What are you left with? X minus y. So that's what I was left with. I took the y minus 3 right here, and I was left with this x minus y here on the bottom. Now this is not new to you. Again, it's just trying to remember or refresh your memory on when you have 4 or more terms, you're going to be doing the regrouping. So that's all we've done, is we've just regrouped here. And now we cannot factor anymore. But can we reduce this fraction? Is there a common factor? Well, in this case, yes, y minus 3. So we can cancel that out, and then we're left with x plus y on top and x minus y. But we got to denote, what can y not be? Well, you're taking this x minus 3, setting it equal to 0, solving, and so we're going to denote that y cannot be 3. So this is your final answer. So that's what you would do when you have multiple variables.